The third function actually is quite known. You should be already aware about it, but it's fine. We can do it as well. This is related to the PDCP function in general, that it can do a split period or routing or even duplication for the packets. But this is, again, it's mainly done in the non-standalone. So this is not related to standalone. And again, this is the bottom left parameters here. This can be again found from the RRC configuration. But again, this is mainly for uplink. Okay, especially for primary path and uplink data split threshold, and even for PDCP duplication. Because downlink will be already configured at GNB side. You can check from the GNB configuration. But from the uplink, the UE should know what he should do. For example, when he can start the uplink splitting if it's going in the uplink direction. So for example, here, if you look into the PDCP here, the DCP layer and the downlink direction, it's having some threshold, internal threshold. It decide to do the data splitting. Okay, so how it will be moving? This is, for example, the 5G buffer at PDCP. It will split the data through the RLC entities for the 5G RLC. Again, this is PDCP for the 5G. It will be splitting the data, moving here. So it will be forwarding and splitting the data or routing the data towards different paths. For example, the first path, it's moving here from the 5G PDCP to 5G RLC. For example, assume this is the packets which should be transmitted. First 3 red for 5G, then the green one for 4G, as you can see here. 3 for 5G, then green one for 4G, and so on. This is how the packets should be transferred. So it will be transmitting first 3 packets here and 1 packet here. And here it will pass through this path, through the PDCP RLC buffer, then it will go through the air interface, and here it will pass through the X2 interface. Why this is important to understand? Because again, sometimes this can impact the reordering. For example, if you have a reordering, I will be explaining this part also next slides. But if you have reordering packets at the receiver, again, the PDCP receiver here, he will be waiting packets from 2 legs, right? So assume that there is a high delay in the 4G leg because, for example, 4G, let's assume speed is very low, okay, or having very bad performance. And also assume that the X2 itself having high delay. So this extra delay can delay this kind of green packets. This means at the receiver side, you will be receiving, assume this sequence number 0, 1, 2, 3, or 1, 2, 3, 4, okay? So the receiver will be receiving the red one, which is 1, 2, 3. 4 will not be receiving, he will receive 5. So the receiver will hold the data because of this reordering stuff until it having the complete sequence. So that's why sometimes it's critical to enable the data split, for example, for very high intersite distance. For example, if you have a neighbor site which is 4G only and you are enabling for this site as anchor layer and you're extending the coverage of 5G too much, this can sometimes increase because the 4G will have a very poor performance, and even the 5G as well, or any of the legs. So this can increase the delay of those packets. So accordingly, can do like kind of data stall, because at the end, the PDCP will not forward the packets to the upper layer until it have the correct sequence here. So you should be very smart when you try to tune the parameters in general, because again, can impact the user experience, the latency, and also sometimes it can make like kind of data stall. Okay, and this is again one important note. This is about the split period and routing. This is a functionality. There is also additional function called duplication. Sometimes this can be configured just to increase the diversity and increase the reliability. Sometimes the PDCP of the 5G will be transmitting the exact same packet through the 2 paths. So whatever packet will be arriving first, this will be successfully arrived. So this is giving a chance to increase the diversity in general, and this can increase the reliability as mentioned here. But again, it adds overhead. But the receiver, in general, the receiver, if received both packets from, because again, it will be duplicated packet moved from the 5G leg and 4G leg, if received at the PDCP or both of them, the receiver will be discarding the packets which is being added. But again, this is increasing the probability of having a much better performance, increasing reliability, and this can be, for example, advantage for the very poor edge areas where you know that, for example, particular area having a poor coverage and so on. So this was the function of the split period and routing. And again, if you listening for each and single word from what I'm trying to say, you'll find that all these kind of things having a relation with timers end to end, because again, this is impacting sometimes the data delivery to the upper layers TCP. So this can still impact your end-to-end latency. So that's why sometimes if you did a trial, for example, for uplink direction, not downlink, to try to, for example, make it more difficult to attune to our, for example, uplink data split threshold. This is the threshold, traffic threshold, where the UE will decide whether he needs to do a split or not. For example, if the data and the buffer of the GNB or BDCP buffer crossing this threshold, any of those values you are setting, this means the UE will decide to do splitting. So assume that you are doing very early. So it's unnecessary. You're moving the data through two legs. This is can again having a less performance, especially if you are in a very good area or good coverage. You don't need to do a splitting because at the end, one leg can, for example, 5G can handle all the thing, all the traffic, all the speed. So in this case, you don't need to do splitting to improve your latency because again, moving towards two legs, especially the 4G and 5G, it will not be that good idea, especially in very good areas, especially also that you have, if you remember, especially if you're speaking about TDD for NR, you have, for example, the scheduling there is 0.5 millisecond, which is one slot, while the scheduling in 4G 1 millisecond. So again, this is increasing your delay. So this kind of things you can consider as well. Let's move forward to see the next function. Okay, if you're speaking about the user plane, especially for the acknowledgement mode, if you're speaking about the RSA acknowledgement mode, we have a retransmission mechanism starting from TCP using automatic repeat request, which is ARQ. You have a retransmission RLC, which uses automatic repeat request as well, and also you have the HARC, hybrid automatic repeat request. But the three of them, TCP or RLC or HARC, all of them can do a retransmission for a specific packet. If you have one packet being received, even specific segment being lost, it can make a retransmission only for that part. But BDCP is not doing this case. BDCP is completely different. And the BDCP retransmission is only happening in one case, okay? This case during the handover. Assume that your BDCP already established, your data being received at the BDCP, meaning that MAC is already flushed, RLC already established, and all the data is being delivered. But assume that you have moved from the source unit B, for example, DU, to the target unit B DU, okay? In this case, there will be a data in the buffer of the BDCP being there in GNB. It was being transmitted within the 4G, the source itself, but it was not yet being acknowledged by the lower layer. So this, once the handover is being done, there is no data forwarding from the source GNBDU to GNBDU, target GNBDU, because in this case, there is no actually interface between the GNBDU. If you read into as per the specific here, the specification, that there is no interface between the use. So in 5G architecture, you don't have a direct interface for forwarding the data. As a result, this is a responsibility from the DCP layer to do the data recovering. As per the 3GPP scope of the BDCP, I'll be sharing the source at the very end of this sessions. The BDCP do something called data recovery, which is retransmission. What will happen if you look into this flow? During the handover, what will happen? The source GNB will forward something called downlink data delivery status from the source GNBDU to GNBCU, okay, the centralized unit. And it will tell him that I have some data which is unsuccessfully transmitted to downlink data DUE. So in this case, the GNBCU will be requesting the BDCP to do the retransmission. So the BDCP data recovery will be started. So in this case, the DCP will support data recovery by retransmitting all the acknowledged BDCP data. It will completely, all the packets will be retransmitted. All the packets which is not being acknowledged yet. It's unlike again, as I mentioned, the automatic request and the HARC mechanism, because both of them supporting the retransfer for a specific and developed packet, while this one will be just directly retransferred all the packets, and this is being needed for the lossless handover, because again this supports the handover scenario.